In the lesson today, we're going to talk about systems of equations, and we're specifically going to look at how to solve a system of equations by using graphing. So if you'll take a minute, please set up your essential question in your notebook, and then restart the video when you are ready. Okay, so the first thing I want to take a minute to do in our notes is I want us to actually define what a system of equations is, because that's something you may not have heard before. And it's really pretty simple. We know a system involves multiple things. So a system of equations is just two or more equations grouped together. Two or more equations grouped together. So normally we're used to just looking at one equation and having to solve that one equation. But now when we look for a solution to a system, the solution has to make both equations true. Has to make both equations true. That's what a solution does. It's something we can plug into the equation and it makes a true statement. But that's what I mean when I say makes both equations true. Remember, because we're dealing with two variables, our solution is going to be in the form of an ordered pair, because we have to have a value for x and we have to have a value for y. And you may have some prior knowledge of solving a system of equations. The main thing that we're going to be looking for here is we're going to be looking for the point of intersection. When we talk about graphing a system and finding the solution is the point of intersection, because that is the point that is on both lines. Okay, so looking at this example right here, I'm sure that you can graph each of those equations very easily. So that's what we're going to take the time to do right now. I'm going to graph y equals x minus 2. Our y-intercept is -2. Our slope is 1, so I'm going to go up 1, right 1, up 1, right 1, or down and left. And so my equation, my graph of this equation is going to look like that. My second equation has a y-intercept of 7. Okay, again, you could probably do this on your own. My slope is -2 or -2 over 1. So I'm going to go down 2, right 1, down 2, right 1. And it's kind of important, you want to draw some accurate points. So if I just drew 2 points and then tried to draw my line, I might not accurately see that point of intersection, and see me even, I didn't draw my line very straight. Here is my point of intersection, and so I would state that my solution is 3, 1. Now I could check this. I could take this point, plug it into both equations for x and y, and I could see that it does make both equations true. Okay, look at the next examples. These are already graphed for you. Okay, so we're just basically looking for this point of intersection. So here's my point of intersection. This coordinate is 4, 8. Simple as that. One thing I might ask you is, could you write that system of equations? And so hopefully we know how to write an equation of the line. If this is line 1, looks like my y-intercept right here is -5. And another exact point would be right here. So my slope would be 3 over 1. So my system for this is y equals 3x minus 5. Okay. And then for my second line, my y-intercept way up here is +9. And my slope, down 1, right 4. So I have a slope of -1/4 x. So we also could look at a graph and write this system. Here you have a second graph. I want you to see if you can find the solution. And I also want you to try to write the system for that graph. Okay, let's look at the next example. Now, this is a table. One thing that you might see from a table is you might have to identify the solution. So hopefully you can see here where the solution is. I'm going to give you a minute to look at that. Looking at that table, where would the solution be? I hope you realize that it's right here where the two y values are the same. Our solution is 2, -11. Now, my next question is, can you write an equation for this? Now, this confuses a lot of people. So what I want you to see here is you actually have two sets of data. You have a set of data for y1, so that would be for the first equation. This kind of divides it. And then you have a set of data for y2, so the x values go with both sets of data. So to write the first equation, I would look at x and y1. So we should be able to see right here, here's where x is 0, so our y-intercept for y1 is -3, and then the other thing we need to find is the slope. So let's see here, it looks like we are moving down 4, and this is counting by ones, and so my slope is -4. So y equals -4x minus 3 would be the equation for y1. Okay, so now let's look at the y values for y2 for our second equation. Okay, again, here's where x is 0. My y-intercept is -15. And I'm going to look at how my y values are changing here. It looks like it's going up 2. We're still counting by ones over here. So our slope is 2. So y equals 2x minus 15. There is our system. Okay, so on this one, I want you to take a minute and see if you can find the solution and write the system, just like we did on that. Okay. The last thing I want you to look at, so here's kind of some steps to think through. So we don't always have our system in slope-intercept form. So if we don't have it in slope-intercept form, then I think you know that we have to solve for y. Then we're going to graph both equations just like we previously did, and we're going to look for the point of intersection. Okay, so that's kind of what our steps are talking about here. So if I have 4y minus x equals 16, I need to solve for y. Remember, you must do inverse operations. Okay, so I'm going to add x. I'm going to divide by 4. Now this stumps us sometimes. Remember, this would be 1/4 x plus 4. Okay, and so now I'm ready to graph that as well as the second equation in my system, which is already solved for y. So again, I'm going to give you a minute to pause on that and see if you can graph it. And after you're finished graphing, you can stop the video and make sure you do your video check quiz.